So we're going to talk about the binomial theorem today, 7c. Do take out your formula packets. There's something I want you to write down in your packet. I'm going to ask you to write it down in your packet, so you should have your packet out to do that. It's really important to look at your packet. I almost messed up the formula last hour because I wasn't looking at the packet, so don't make my mistakes. And since this is a pretty complicated topic that can get kind of tricky, I did kind of take the notes slow, and we didn't even finish all of them last hour, so just kind of keep in mind, stick with us. We'll see what we can do here. We may or may not have time for the stop box, so you can write that down. And this is the binomial theorem. Okay, you ready? So I've tried something a little bit different this year that rather than jumping into the notes, I want to start with kind of a review of some things that you should know, but I noticed people being confused about. So what's a term? That is an example of a term. How do you describe it? Okay, I'm going to help you out. Let's say I write this trinomial down. I'm just making this up. But let's say I had like, a binomial squared. We FOIL that, we get a trinomial, right? So what if my trinomial is 3x squared minus, 10x plus 7. I just made that up. It might not be factorable, so don't think too hard about it. What would be a term? Close, you're close. 3x squared is one term. It's the first term, because it's the first one in the list. So I do want to make sure these are pluses. So negative 10x would be the second term. 7 would be the third term. And since it's a trinomial, there are only 3 terms. But we know on Tuesday we had stuff that had like up to 7 terms, right? And we're going to have stuff that is even more than that today. But are we okay with that word term? And if I said, okay, what's the second term? You would say, well, that's negative 10x. Okay. So then Miranda brought up the second word. What's a coefficient? Yeah, coefficient is the number in front of the variable. I don't know that you need to write this down, but I just knew it was helping some other people in second hour when I actually wrote that down. So what's the coefficient on the first term? 3. What's the coefficient on the second term? Negative 10. So that's something like today, this one was easy, right? Because it's a short one, it just has 3 terms, but we're going to be able to find the coefficient on something, even if my expansion is up to 20 terms. So I'll be able to find that coefficient without having to do the full triangle and stuff, but I just want to review those words. What's a constant? Or I could phrase it this way, what is the constant term in the trinomial I wrote up there? 7. So how would you describe 7? How is 7 different from the other terms? No variable. So the constant term is a number with no variable. Again, that shouldn't be a new word, but I know sometimes we don't use the words all the time, we kind of lose them. We're going to come back to constant. I'm not quite done with it, but what's a power? Or what's an exponent? A power. Okay. So here I've got x squared, I've got x. If I had x, what would be the power or the exponent on that constant term? Not 1, because this is 1, right? You see where I'm going with this? Because x to the 0, what does x to the 0 equal? So my constant term would have a variable with a power of 0 that will come into play a little bit later today, the very end, the last example. So just keep in mind, to have a constant term, to have no variable, you need that variable to disappear. And the way it will disappear is if it has a 0 on your exponent. Okay, are we okay? Then I just put a few exponent laws to remember. These are all from chapter 3. They're all straight out of the 3 be notes straight out of your textbook. Old news, but just a reminder, we're going to use all 3 of these today, so I just wanted to bring those up. Remember that if you have things that you are multiplying all to a power, you have to put that power onto each part. We're going to use that today. Remember that if you are having a power to a power, you have to multiply the powers. And if you are multiplying the expressions, you add up your powers. We're going to use all of those today. I guess we're going to use this one. I didn't think to put it down here. And while I was teaching second hour, I thought of another one that I could have put down here, but I didn't. So if I have this 1 over x, and I want to bring that x up, actually that'll be x, let's say x to the n. Oops, make that nicer. If I have 1 over x to the n, but I don't want it in the denominator anymore, what would I do to bring it up? X to the negative n. So for future, I think I'll put that one down there, but when I had this epiphany this morning to add this into the notes, I didn't think of that one yet. So just to review, again, all of those things we should already know, but just to make sure we're all feeling good going into what we're doing next. Okay. So now we're going to get actually into the theorem. And I wonder, if I can do what I want to do. I want to go here. Yes, but I didn't erase all that, so that's not helpful. All right, so I don't want you to panic about this. I honestly only think that there's one part you really, really need to write down, and this is in your packet. The part that I really need to write down, and I'm going to actually zoom it in just a touch here, is this piece right here. That whole thing, that whole top line is in your packet. And what I want you to write in your packet is I want you to make that same circle that I made. Because that is the most important part, and that's really the only part of this that you have to like remember and use. And I've noticed in the past when people try and fill out like the whole formula, they get really confused. What this is saying is that I can take any expansion out to any number here, and I can find out all those coefficients. So on my first term, I wouldn't have really a coefficient, but I can find the coefficient on my second term by doing this, so on. Somewhere in the middle we have this, and then we end up at the end. So what it is a formula for finding what we were finding using Pascal's triangle. But it's for when we have really big numbers that it's like unreasonable to actually use Pascal's triangle. Did everyone circle that in their packet? You got it, packet. Circle it. And then, remember we did this yesterday, right? And this is also in your packet, but if you want to rewrite it down, it was this. Or we could do the NCR, right? So if you want to write that down, that is in your packet, but just a review from yesterday, that's what we did yesterday. So what we're going to do, and we have one other formula thing we have to talk about first, is we're going to get a binomial expansion, like a binomial to a power, and we'll figure out, okay, what's A? You know, what's the A part? What's the B part? What number is N? I'm going to talk about this next. What number is R? So we'll get to that next. You don't know how to find that yet. And then we're just going to put A, B, N, and R into this formula. Okay? There we were. Okay, so this is not quite in your packet, but I don't think you really need to. I wouldn't even worry about the bottom line. Don't bother writing this down. I'm going to tell you the one thing you need to write down. So I just circled the same thing I circled before. The general term is R, the R plus 1th term. So T stands for term, so this is what you really need to know, is that R is 1 less than the term number. That's what you really need to know. That's not in your packet, so that's something that you need to remember. But that's what you really need to write down. And they have it up there in all technical terms, but you really need to know r is 1 less than the term number. Is anyone freaking out yet? So we're going to go over 3 types of examples if we have time. Like I said, we didn't have time to fully do the work on the 3rd example, but I was able to talk about it in the 2nd hour. And so we're going to do the first example is going to be where r is pretty easy to figure out. The 2nd example, we're going to have to do some more work to figure out r. Okay? So this example is find the 9th term of this binomial expansion, 2x squared minus 1 over x to the 21st power. So what that means is that I'm going to find the term that's the 9th term in the list. So we looked at that trinomial at the 1st, 2nd, and 3rd term. But now we're going to find the 9th term in this expansion. Bonus question, how many terms will there be? We talked about this on Tuesday. 22. Remember, the number of terms is 1 more than that expansion number. Okay, so remember that there are the number of terms is 1 more than the expansion, so there's 22. So there's 22 different terms in this whole huge thing. Which means if we did Pascal's triangle, do you see how that would be kind of ridiculous to go that far down? And like have all of those. So we're going to use this formula to get there. And so we can figure out, I'm going to write the formula down and hopefully do it right this time. So n above r, a to the n minus r, and b to the r. So that's what you circled in your packet, okay? Now we remember that we use a plus b to the n. So that will help us figure out the a, the b, and the n. So what's a? 2x squared. Be careful on what's b. It is negative, because we would make it plus a negative, so it matches that. So b is negative 1 over x. What's n? And r is the hardest part, so we'll save that for last. Everyone really clear on a, b, and n? Because a, b, and n are just as easy on every single problem you're going to get. The r is what's different. The r is what gets tricky. This is the easiest type of problem for the r, though. Because remember, r is 1 less than the term number. So if I'm looking for the 9th term, what's 1 less than 9? So r will be 8. So that's kind of the easiest type, is they tell you, oh, it's the 9th term. You can just subtract 1. We're going to get the harder problems next. But is everybody okay so far? So now what we can do is just put all of these things. Actually, time out. We're going to do one other thing that I discovered with 2nd hour. This is the benefits of not being first. When I was working with them, I realized that it might be easier to deal with this right now. Like, x in the denominator is a pain in the butt. So right now, let's switch that. So we talked about it. If I'm bringing that up, what would the power on the x be? So that's positive 1, so that would be x to the negative 1. It will make your life easier if you just do that right away and you don't have to do it later. At least I think. And you can tell me like tomorrow or Monday, like, no, it really doesn't matter, and then I'll change my ways. But I think it'll make your life easier if you do this right here. All right, so then we will just put everything in. So n above r, so that would be 21 over 8. And parentheses are like your best friend here, so I'm going to have 2x squared to the 21 minus 8 power, n minus r, and then negative 1x to the negative 1 to the 8th power. Now, we're going to take this in a couple of steps here. The first thing, I'm just going to simplify that. I'm just going to do 21 minus 8 and leave everything the same here. What is 21 minus 8? 13. Okay, so this answer right here is without simplifying. Now, I know that there's some on your assignment that say, give the answer without simplifying. So you can stop there. However, on your test, I want you to simplify all of them. So we're going to simplify this one, and it's going to be a ginormous number, which is why we would do it without simplifying, but let's just practice it. Okay. So we already talked about coefficients. Do coefficients go in front of the variable or behind the variable? In front. So I'm going to put all the number parts in front right now. Okay. Use your calculators to do 21 over 8. Or if you want to do it longhand, I'm going to stop you. Or 21 above 8. It's going to be like a number in the 100,000, so don't panic. 203,490. Now remember, this 13 has to go on both parts. So I'm going to take this in a couple of steps. That would be 2 to the 13th power. And this would be x to what power then? 26. Same thing here, I have to put the 8 on both parts. So I would have negative 1 to the 8, and then x to the negative 1. Wait, what would that power be then? I don't need to do that 2 steps. I can do that in my head, right? So timesing those, that would be x to the negative 8th power. If I've done something you're confused about, you should tell me, because the next one will get harder. Yes. I did the binomial. So this one's it's in your packet. So you would do 21 over 8 and then 21 minus 8 factorial, or you can do a shortcut and do 21C8, which is, to be honest, what I did, saving some time. Okay? I'm glad you asked, because like you're gonna have to do that on the next one. So now that's still the same. What's 2 to the 13th power? Yep. I was like, that did not sound right to me, but it is. Now I'm going to actually bring this over so that my number parts are all in front. Like we already said, we want the coefficient to be in front. So what's negative 1 to the 8th power? 1. And then I'm just rewriting these for a second. So now to get our final answer, we have to multiply all these numbers. Your answer will be in the billions, so don't panic about it. And like I said, that's why we don't always simplify, but I just want to go through it because you will have to do it on the test. So I'm just going to go for it here. We've got 1,666,990,080. That's my coefficient. That's ginormous, right? And then, now what do I do with these to combine my x's into one x? You add up those exponents, so 26 plus negative 8 is 18. So that then is my term. It is ginormous. It's gonna be, so in my whole list, if I had them all listed out, I would have x to the 18th at that very end there once I combine everything. Now we're gonna do some similar stuff, even though the next problem does get harder. Do you guys kind of get what I was saying with like moving the coefficient parts to the front and moving the variable parts to the back? Because we're gonna do that in the next one too. Can I erase? Okay. Okay. So we'll start. I want you to start the next one by finding a, b, and n again. So in this time, we're going to find the coefficient of the x third term, the term that has x to the third power in the expansion of 2x squared minus 3x to the sixth power. I know it's probably tempting to just pull out your Pascal's triangle and go for it there, but we are going to use the binomial theorem to get there. Did everyone pick out 2x squared as a? Negative 3 over x is b. And then what we can do is change that to negative 3x to the negative first power. I do think it's going to help us like save a step later if we take that step right now. What's n? 6. And the big problem is we don't know r. Like right now, we don't know if x cubed is going to be the first term, the fifth term. Like we don't know where x cubed is going to be, so we can't figure out what r is yet. What we are going to do is we're going to plug those three things in, and we're just going to leave r as r to start. So it will look like this. So n is 6 above r. 2x squared to the 6th minus r, and negative 3x to the negative 1 to the r, because I don't know r, so I just plugged in everything but r. That was wonderful. Okay, it was good. So, oh my god, I'm trying to decide how fast I want to take this. So what we're going to do is we're going to bring our coefficients to the front right away. Okay? So anything that's just going to be a number, we're going to put in front, and we're going to put our variables in the back right away. When I plug a number in here, that will be a number. Can we agree with that? So I'm going to write down, actually I'm going to change my colors here. So I'm going to do this part in green, okay? So I'm going to put my coefficient in green. So I've got 6 over r. Even though I don't know what r is, it will just be a number. The 2 part is just going to be a number, right? So I'm just going to bring this 2 part here. So 2 to the 6 minus r. Just the 2 piece, because that will be a number. I'll plug r in, I'll 2 to whatever power, and then I'll just get a number. I'm going to have to put the r on both stuff here, but negative 3 to whatever r is will just be a number answer. So that's negative 3 to the r. Now I didn't write this down, but if like you want to write a note, put the coefficients in front. Like that's what I just did. That's what I did in green. I just pulled the coefficients to the front. Now I'm just going to put the variables to the back. So this is going to be a variable here. So that's going to be x squared to the 6 r power, and that's got a variable, so that's going to be x to the negative 1 to the r power. So coefficients in the front, variables in the back, just like normal. I mean, it looks super, super weird, but it is normal for us to put the coefficients in front. And see how we sort of did it at the end of the last example? I know, I'm taking it slow, but we've got 2 days of review, so we will be fine. Okay. Now, we're going to leave this stuff in green, and we're not going to touch the coefficient piece until we figure out what r is. One thing I know is I know what the exponent is supposed to be on my x. What do I want my exponent to equal? If we go back to the problem. 3. So I want my exponent to equal 3. See where Joe got that? So what I can do is I can use all my skills, and I combine this so I just have x to a power. So I'm going to use those skills that I brought up earlier. So I know I have to distribute this, so that's going to be x to the 12 minus 2r, right, if I distribute that 2. And if I do power to a power, I have to multiply that, so that's going to be x to the negative r. So those are some of the skills that I brought up earlier. One last step to putting it so I just have x to 1 power. I have to add this. And I know like everyone has different skills, so maybe you can add that in your head. If you can't add it in your head, go ahead and just jot it down. 12 minus 2r minus 1r. You know, what will that be then? Yeah, so negative 2 plus negative 1, that's going to be minus 3r. So if you need to go off to the side to do that, go ahead. But then this will be 12 minus 3r. So we already said it, or Joe did. This right here is supposed to equal 3. So I can make a little equation off to the side for this. So that means that 12 minus 3r equals 3. So what should r be then? So if I do 3 minus 12, I get negative 3r equals negative 9. Then I divide by negative 3, r equals 3. Now that's just a coincidence that it's the same as the exponent, okay? Like don't think that that's a thing, just a coincidence on this problem. But now we can just plug 3 in. So you could rewrite it. I'm just going to be a little lazy and write it on top. But I can plug that 3 in and do exactly what we did on the last problem and just evaluate all of those. So we can use our calculator to evaluate 6 above 3, or we can do it the long way. So that's going to be 20. Now 6 minus 3 is 2 to the 3rd power. So what's 2 to the 3rd power? 8. And then I can do negative 3 to the 3rd power. I want to pause to make sure everyone is good with those. Finding those 3 numbers. And this 6 above 3, that's what we did yesterday, so you can always go back and look at that if you need help on that. Now we just need to times those all up to find the coefficient, and we should get negative 4,320. That is my coefficient. Now you might have some that say, like last time, find the term. If the directions said term, you would just keep that x3 as part of your answer. Like if it says term, we know term is the whole thing. If it says coefficient, we know coefficient's the number in front. So keep that in mind. We have 11 minutes? 11 minutes. We'll get through this, but I think I do want to speed it up a little bit, but other questions? Okay, so the next example is actually going to have the exact same expansion, okay? So A, B, and N are the exact same. It's the same expansion, but a different question. We've done that before. We have like different questions within the same like beginning part. So this work that we did here is all the same. So I think what I'm going to do, I'm going to rewrite this part back with the R's. But I think I'm just going to leave this work up. I'm going to see if this works. I don't know. It might not work when I change the next page, but I'm hoping it will. Oh my gosh, look at it does. So in this case, the difference is we have to find the constant term. So not the x to the third. We're looking for the constant term. So we do all the same things. And would it help if I rewrote that and started over? I'm going to do that really quickly. So we would start this problem the exact same way, where we've got A, B, and N. And so plug those in there. So this would be, not N, this would be 6 above R, and then 2x squared to the 6 minus R, negative 3x to the negative 1 to the R, just like before. And just like before, I'm going to put the coefficients in front. So 6R, 2 to the 6 minus R, and negative 3 to the R. So same thing, put my coefficients in front. And it's the exact same problem, so they're the exact same as before. But here's the difference. I want a constant term. That means I want my x to completely drop out. So what would my exponent be if it's a constant term? It's going to be 0. So that means down here, instead of equaling this, because we do all that same work, and it's the exact same problem, so that's why I'm not redoing that work, because it's the exact same, is I take this equal to 0 to find R. So you got to split up the coefficients, you got to split up the variables. Once you put it all together, you got to go back to your problem to figure out what you want your exponent to be. And in this case, since it's a constant term, we want our exponent to be 0. So then we can find out what R is. Good, so this time it's 4. Because I have negative 3R equals negative 12, R equals 4. And so we can go back here and plug in 4 for all of these. And that's going to be 2 squared. So 6 above 4 is 15, right? And then 2 squared is 4. And negative 3 to the 4th power is positive 81. And then if I multiply that, I'm going to have 60 times 81, which I think is 4,860. Okay, there is about 6 minutes left. When is your test? It's Tuesday, so we have 2 full days of review. I highly recommend actually, doing your homework tonight and then, getting that practice, because it's one of those things, it's not easy to do. The more you do it, the better you get at it. So do that. We don't really have time for questions on 7B, and I know that there are a couple of tricky ones, so we can do those 7B questions tomorrow. So I think it was number 3. Does anyone know what I'm talking about? Number 3 yesterday was like the tricky stuff, so we can go over that tomorrow together. Oh my goodness. The stat box is just what you need to remember about finding the constant term. What does the exponent have to equal if it's a constant term? 0. Okay. So do your assignment, get that practice, don't start panicking. We've got all day Friday, all day Tuesday. If you have to work it out, you're going to get a nice review tomorrow that will make you prepare for the test. But like, I wouldn't skip the assignment because the test is pretty short. It's a short chapter, so it's a short test. So it's a short review. You just got to make sure you know how to do it.